Hi everybody, welcome back. In this video we're going to cover both the dimpled and the convex limacons. We're going to do them two of each. That should be enough for you. Remember, a dimpled limaçon is an effect where a over b is between 1 and 2, 3 divided by 2 is between 1 and 2, and 5 divided by 4. This is going to be in the positive y direction. We're going to go ahead and work this one all the way out and plot them as we go. If theta is 0, you get out a 3 for r. If theta is pi over 6, the sine of pi over 6 is 1/2. 3 plus 1 is 4. 1, 2, 3, 4. If theta is pi over 2, you get out a 5. 1, 2, 3, 4, 5. 5 pi over 6 is the same as pi over 6. You get out a 4. When theta is pi, you get out a 3. 7 pi over 6, theta's got a sine of 7 pi over 6 is negative 1/2. So 3 minus 1 is 2. 3 pi over 2 would be 1. And then 11 pi over 6 and 7 pi over 6 would be the same. And what you see is we started here, worked our way around. It's a beautiful circular function. And then things pulled it away where it's going to be a little bit of a dimple right in there. Okay. Symmetry with respect to the old y-axis, or now the line theta equals pi over 2. Max r is 5. Okay. Never hits the pole. In this case, number 2, we're going to say r is equal to 5 minus 4 cosine theta. We're going to go in the opposite x direction, so it's going to be pointed that way. And you can start plugging in some values, or you could say, hey, let's use these numbers. 5 and 4 is 9, 5 minus 4 is 1, 5, 5. Now, I said 9. This only goes out to 7, so we're going to do our scale by 2's. Let's plot it. When theta is 0, r is 1. 5 minus 4 is 1. When theta is pi over 3, r is 5 minus 2, which is 3. 1, 2, 3. When theta is pi over 2, r is 5. 2, 4, 5. 2 pi over 3, theta is going to be 5 minus 4 times negative 1/2. Or 5 plus 2, or 7. 2, 4, 6, 7. Pi, we're going to get 9. 2, 4, 6, 8, 9. Let's do that again. 2, 4, 6, 8, 9. 4 pi over 3 and 2 pi over 3 would give you the same exact answer. 3 pi over 2 and pi over 2 would give you the same exact answer. What did I do here? 2, 4, that should be there. 2, 4, 5, 2, 4, 5. We're great. That's not there. And then you can do the same thing here. This is 1, 2, boom, boom. And what happens, we know, is we started here, went to here, came around, did our thing, came around to here, and had to come back in. So over there you have a dimpled limaçon. Now for convex, very similar to dimpled, this will not hit the pole at all. None of these will hit the pole because it's impossible. The largest this can be is 1, 3 minus 1 is 2, and so forth. So 3 minus 2 and 3 plus 2 will never get you to 0. Here, we're going to start the same way. It's going to be in the negative y direction, And you can do some of the values, 4, 4, 1, 1, 3. That's all it is. Now, what do I mean by that? 5, 4, 5, 4, 9. Doesn't matter. Let's plug in a 0. When you plug in a 0, you get out a 4. 1, 2, 3, 4. When you plug in a pi, you get out a 4. Let's just do them both at the same time. When you plug in a pi over 2, you get out a 3. When you plug in a 3 pi over 2, you get out a 5. When you plug a pi over 6 or a 5 pi over 6 in, you get 3.5. When you plug a 7 pi over 6 or an 11 pi over 6 in, you get what? 4.5. So this looks like it's going to be almost a dimple in here, but it never came back in. So the idea is we started here, we flattened out in here, and we came back around and it larger in this direction. Almost looks like a circle, not necessarily. Okay. Here, 4 divided by 2 is bigger than or equal to 2, I should have said. Excuse me. This one is going to look really close, the closest dimple or convex that you will have. So cosine, positive x direction, so it's going to go that way. Plug in a 0, you get out of 6. 1, 2, 3, 4, 5, 6. All right. I plug in a pi over 2, I get out of 4. 1, 2, 3, 4. 3 pi over 2, I get out of 1, 2, 3, 4. Plug in a pi, I get out of 4 minus 2, I get out of 2. Okay, so you should at least be able to get those values. We know where it's going to go there. If you plug in a pi over 3 reference angle, we will get out of 4 plus 1, which is a 5. 1, 2, 3, 4, 5. Same thing with the same reference angle here. If you plug in a pi over 6 reference, a pi over 3 reference angle in either of these quadrants, cosine of 2 pi over 3 is negative. So 4 minus 1 is 3. 1, 2, 3. 1, 2, 3. And there, that should be plenty enough points. If you want to plot more, go right ahead. When we started out, we plotted, we went through here, we went through here, flattened out a little bit in there. Like I said, this is going to look like a convex. It's the closest one that you will get where A over B is equal to 2. So this is my video on plotting dimpled and convex. Hopefully you look at some of the others and figured out how to do them. I'll post some Desmos activities to help you as well.